Welcome back. We're going to look at redox reactions, reduction oxidation reactions, in which parts of the chemical reaction are going to change charge. Redox is the short name for reduction oxidation, and when we talk about redox, you can't have just a reduction, you can't have just an oxidation. They come coupled together. You have to have them simultaneously, at least one of each. In a reduction, the overall reduction process is going to become less positive. It's going to gain electrons, and since electrons are negative, the positive charge of that portion of the chemical reaction is going to reduce. And then on the other hand, the oxidation is going to become more positive because you're going to lose electrons, and since electrons are negative and you're losing them, you're going to become more positive when those electrons move somewhere else in that chemical reaction. So you must have that reduction and that oxidation. You can't have just one part. So here's an example of how that's going to work. We have sodium, which is going from sodium 0 charge, and it's going to move over to sodium plus 1 charge on the right hand side of the equation. Now this is going to be the oxidation portion of the reaction because we're losing electrons. These electrons are going to go somewhere else. And those electrons, since they are negative charge, cause a plus 1 charge to occur because the sodium is losing those electrons in the oxidation portion of this reaction. On the other hand, the aluminum is going from a plus 3 ion into a 0 charged element. It is gaining these electrons that sodium happens to have, and it's dropping them right there. Now, you can't have just a reduction and you can't have just an oxidation because there needs to be an electron gainer and an electron loser in order to make this type of reaction occur. See what else we have. So then sodium goes from a 0 charge to a plus 1 charge, aluminum goes from a plus 3 to a 0, and that's how we get our reduction oxidation. We have a couple mnemonic ways to remember what's going on for a redox reaction. We have one called oil rig, and the other one is called Leo, the lion says gur, where the first letters of oxidation is losing is oil, and then reduction is gaining is rig, or Leo the lion says gur. Leo is losing electrons, oxidized, gaining electrons, reduced, and there's your gur. Pick one of these two mnemonics to remember. You don't need to know both, but then practice using that every time we do a redox reaction. We typically see these in single replacement reactions on our worksheets, but we do have redox reactions in many different types of reactions. We just practice them mostly in single replacement. So for example, here's a single replacement reaction where I have aluminum element and then I have an ionic compound. Aluminum and iron are going to trade places. Notice that aluminum is an uncharged element. Iron is a charged particle in an ionic compound, and then they trade spots, so there must be a movement of electrons during that process. In order to write out redox and determine what's being reduced and what's being oxidized, you're going to write a balanced chemical equation. Start with that just like normal. Then you're going to circle your spectators and then come up with a net ionic, and then connect the like particles. So on that first example, we had sodium and aluminum. I connected sodium to sodium and aluminum to aluminum. And I would evaluate using the mnemonics either oil rig or Leo the lion says gur. So that's basically what you need to do. After watching this presentation, I hope you have an understanding that reduction oxidation is the full name for redox. You can't have just a reduction or an oxidation. They come coupled together. And reduction is gaining electrons. It's going to drop the overall charge of that particle, whereas oxidation is losing electrons. It's going to raise, become more positive, the charge of that particle. And we're going to draw these out when we're looking at net ionic equations, mostly for single replacement for our class. Hope that helps.